Modern base language models are versatile generalists. Out of the box, they can write poetry, summarize dense PDFs, and brainstorm marketing copy. But when you hand them a specific multi-step enterprise task, they behave like overconfident interns left alone in a control room. Developers trying to build actual products are hitting a wall. Even with the latest models, if you ask them to reliably execute complex programming tools or pull facts from a proprietary database, they will eventually hallucinate parameters or confidently invent company data. To graduate an AI from a clever chatbot to a production-grade application, you have to make a hard architectural choice. You have to decide whether your primary problem is a lack of context or a lack of specific behavior. There are two main engineering paths to solve this. You can give the AI a searchable reference book, known as RAG, or you can rewire its internal logic through fine-tuning. Choosing the wrong path for your specific use case means a service that fails when it matters most. If a banking bot hallucinated a wire transfer or a legal tool missed a filing deadline, the resulting liability could end a project before it even launches. Every developer wants to reach the top right of this capability chart: high knowledge and high reliability. But getting there requires serious capital and a rigid alignment between your software structure and your business goals. Reliable AI is not achieved by writing increasingly clever prompt instructions. It is a strict structural engineering choice, dictated entirely by how often your data changes and the budget you have to build it. Let's start with Retrieval Augmented Generation, or RAG. Think of this as bolting a dynamic search engine directly onto your AI. If your application relies on volatile, frequently updated knowledge, this is your best option. Instead of relying on what the model memorized during its initial training, a RAG architecture intercepts the user's prompt and routes it to an external vectorized database, like your company's live knowledge graph. It extracts the relevant documents, bundles them with the original prompt, and feeds the entire package to the language model. The AI now has a verified real-time reference sheet to look at before it formulates a single word of its answer. Because the model is just reading the information you provided, its knowledge is always perfectly current. You can update your internal wiki, and the AI knows about it immediately, with zero additional computational training costs. But that retrieval step introduces a core performance limitation. Searching a database and bundling text takes time, which increases latency and leads to slower response times for the end user. Maintaining this pipeline also means constant, active indexing of your external databases. You have to carefully manage data privacy, ensuring the AI only retrieves documents the specific user actually has permission to see. Most importantly, a RAG system is a victim of the garbage in, garbage out rule. The AI relies entirely on the quality of your search algorithm. If the retrieval step pulls the wrong document, the AI will still confidently give the user a wrong answer. RAG perfectly solves for deficits in knowledge. It gives the AI facts, but it does absolutely nothing to fix poor decision-making, flawed logic, or erratic behavior. If your problem is behavior, you have to look at fine-tuning. This involves retraining the model's neural weights to embed deep domain expertise and force it into consistent output patterns. The input requirements here are grueling. Engineers can't just connect a database. They must manually curate thousands of highly specific, high-quality examples of the exact behavior they want the model to replicate. This creates an extreme upfront cost. Your team will spend months just cleaning and formatting data, and then you will pay high computational cloud costs to run the actual training cycles. But the outcome justifies the expense. A fine-tuned model stops guessing. It can reliably execute highly specialized tasks, like triggering complex internal APIs with perfect formatting, without hallucinating the required parameters. Techniques like RLVR, reinforcement learning with verifiable rewards, make this even more effective. This serverless training method forces models to generate multiple responses and evaluate their own tool calling accuracy, updating their policy to favor exactly what works. This bar chart shows exactly how powerful that structural change is. In a recent evaluation by AWS, a model fine-tuned with RLVR showed a 57% improvement in exact tool calling accuracy compared to its base model counterpart. The trade-off is rigidity. A fine-tuned model becomes highly specialized to the exact data it was trained on. If your company updates its API endpoints or changes its core business rules, you cannot just drop a new text file into a folder. You are forced to undergo that expensive, time-consuming retraining process all over again. Fine-tuning guarantees exact behavior and flawless execution for agentic tasks, but it completely isolates the AI from real-time, changing world data. Building a true flagship application often requires moving past a single architectural choice and implementing a hybrid system. This means taking a behaviorally fine-tuned model and layering it directly on top of a dynamic RAG pipeline. The result is an agent that follows complex execution logic while referencing live facts from your internal data. But the trade-off is severe. You are choosing maximum infrastructure complexity and the high operational cost that comes with it. A hybrid system demands dedicated engineering teams to simultaneously maintain the retrieval data pipeline and manage the model's neural weights. If you want truly autonomous agents running your workflows, this hybrid approach is the only way to get there. It represents the true hidden cost of reliable production AI. This decision tree shows the overarching rule of thumb for all AI developers. Use RAG for knowledge and use fine-tuning for behavior. So look at your product. Does your data change frequently? If you are budget conscious or building internal HR bots, basic customer support, or document search tools, you should immediately route to RAG. It is cheaper to build, faster to deploy, and protects your company from feeding users stale, outdated data. Now, if you are a performance-first developer, you need to ask a different question. Does your AI need to trigger workflows, write exact code, or operate in high-stakes environments like medical or legal tech? For these agentic tasks, base models absolutely cannot be trusted with prompting alone. You must invest the time and capital into fine-tuning. Finally, if you are an enterprise architect, ask if your flagship product requires strict compliance, real-time data, and flawless autonomous execution. To build that, you must accept the hybrid model and pay the infrastructure tax for ultimate reliability. We have to stop treating language models like magic, omnipotent boxes that can solve any problem with a clever prompt. Reliable AI requires treating these models like uncalibrated engines. You have to choose your architecture based strictly on the specific data fuel you have and the exact behavioral torque you need.